Okay, so I think we have time for one more question. Question 10. What are polar and non-polar covalent bonds? So non-polar covalent bonds, I'll just write it as CB. This is when your two atoms have equal or similar electronegativity values. So the difference in electronegativity is typically equal to around 0 or 0.5. And some examples include like diatomic elements like nitrogen and nitrogen, and carbon bonded with hydrogen is a nonpolar bond as well, since they have a similar electronegativity value. When we have a polar covalent bond, this is pretty much the opposite. The two atoms have dissimilar electronegativity values, leading to a dipole moment. So typically the differences in electronegativity is around 0.5 to 1.69. And some examples, hydrogen and oxygen, or like phosphorus and fluorine. Okay, so notice that covalent bonds will always include nonmetals. When we have an ionic bond, this is between a metal and a nonmetal. So every time you see a metal being involved in the bonding, then we know that it is ionic. And for the difference in electronegativity, it's typically greater than 1.7. So an example of this would be like potassium fluoride. Okay, so that's how you differentiate between all the different bonds. The junior tutor said, when two atoms sharing electrons form a bond, partial transfer of electron density from one atom to the other may occur, depending on the relative electronegativities of the two atoms. Difference in electronegativities develops a partial ionic charges due to the unequal share of electrons. Greater the electronegativity difference, the more ionic the bond is. Bonds with partially ionic and partially covalent character are called polar covalent bonds. On the other hand, when there is an equal sharing of bond electrons, the electronegativities of the two atoms become equal, leading to the formation of nonpolar covalent bonds. Methane is an example of a nonpolar covalent bond due to the very small difference in the electronegativities of carbon and hydrogen. Water, on the other hand, exhibits a polar covalent bond because of the differences in electronegativities between oxygen and hydrogen, creating partial negative and positive charges. Yep, so this solution is correct.